So, in this video, we will see how to draw the shear force and bending moment diagrams for simply supported beam. Simply supported beam means there are two supports in the beam for the beam. One is hinged support, another one is roller support. So this is the simply supported beam which I have considered to explain the shear force and bending moment diagram. This beam is acted upon by a simple point load. That load is acting at half of the length of the beam. So this is L by 2, this is also L by 2. As usual, the first step is you have to find out the reactions at the supports. So at this support, the reactive force is RA. At this support, the reactive force is RC. I have not considered horizontal force here because only vertical external forces are acting. Now, I am going to take moment about this point A. So RA is passing through that point itself. So distance is 0. So RA multiplied by 0. W multiplied by, because I am taking moment about point A, I need to find the distance from point A up to W. So this distance, it is nothing but L by 2. So W multiplied by L by 2. RC multiplied by, because I am taking moment about A, distance of RC from A, that means this distance which is L. So RC multiplied by L. So I am taking moment about A. So I am assuming clockwise negative, anti-clockwise positive. So about A, W is contributing negative moment. About A, RC is contributing positive moment. I can find RC. Then I can take all the vertical forces equal to 0. So there are three forces here. One is RA, another one is W, another one is RC. Okay. So RA and RC are positive. W is negative. So RA plus RC equal to W. I can get the value of RA. Okay. So I know the value of RA. I know the value of RC. But in this case, both are equal. In this case, because the load is symmetric. So this is the beam which I have considered here to draw the shear force and bending moment diagrams. I have replaced the reactive forces, the supports with reactive forces. Now I want to determine the shear forces. So I have taken one section here and another section here. I am considering the left side part of the section. So left side part means this part for section 1-1. Left side part of the section. For this section, the limits are x equal to 0 and x equal to L by 2. This is the beam for which the section is valid. So here x equal to 0, here x equal to L by 2. So when I put x equal to 0, I will get the values at A. When I put x equal to L by 2, I will get the values at B. So this is the section part. Now, because I have considered left side part, upward force is positive, clockwise moment is positive. Shear force is net of all the forces. There is only one force here on the part which I have considered, and it is acting in upward, so plus W by 2. So when I put x equal to 0, I will get at A. I will get, when I put x equal to L by 2, I will get at B. Because there is no x term here, both the values are same. Then bending moment. Force multiplied by distance. There is only one force here. So force multiplied by distance is x. So W by 2 multiplied by x. Now put x equal to 0, you will get at A. Put x equal to L by 2, you will get at B. Then go to the second section. Again, I am considering the left side part of the second section. So I have considered the left side part of the second section. This section is valid from L by 2 up to L. From L by 2 up to L. Shear force is net of all the forces. There are two forces here. One is W by 2, another one is W. Left side part means upward positive, downward negative. So W by 2 is positive, W is negative. So shear force equation. This is valid from L by 2 to L. When I put x equal to L by 2, I will get shear force at B. When I put x equal to L, I will get shear force at C. Then bending moment equation. Force multiplied by distance. Distance is to be taken from section. So all the distances are to be measured from this point. So force W by 2 multiplied by distance from this point is X. This force W multiplied by distance from section 2 to is this. This is nothing but X minus L by 2. So W by 2 multiplied by X, W multiplied by X minus L by 2. Sign convention about this section, W by 2 is clockwise, so positive. W is anti-clockwise, so negative. Then put X equal to L by 2, you will get bending moment at B. Put X equal to L, you will get bending moment at B. Once you know all these values, you can draw the shear force and bending moment diagrams. So I got W by 2 at A, W by 2 at B when I take section 1, 1. Again, minus W by 2 at B, minus W by 2 at C when I take section 2, 2. So this is the shear force diagram for simply supported beam. Bending moment. First section, at A 0, at B WL by 4. Second section, at B WL by 4, at C 0. So I got the bending moment diagram. So for a simply supported beam with point load, this is for the bending moment diagram. No, I am going to take a simply supported beam with multiple loads and UDL. So this simply supported beam is acted upon by 2 point loads and a UDL here. The first step is I want to determine the reactions at the supports. So here you are going to have one reactive force and here you are going to have another reactive force. So for each force, what is the magnitude, and to find the reactions, I am going to take moment about A. So I am going to measure distance from A also for each force. So first force is RA, distance from A, because that RA is passing through A itself, so distance is 0. Another force is 50, distance from A, distance of 50 from this point, 2 meters. 40, distance from A, distance from this point up to 40. This is 4 meters. RB, distance from A, that means this total distance. Total is 10 meters. Now see the UDL. Intensity is 10 kilonewton per meter. What is the length over which UDL is acting? This is the length. Over this length it is acting, and this length is 4 meters. So UDL length is 4 meters. So 10 multiplied by 4 will give you total force. Intensity multiplied by total length over which it is acting, not the beam length. So total 40. Where it is acting? Half of this length. This is 4. This is 4. Half of that is 2. So at 2 it is acting UDL. At 2 UDL is acting. So exactly at this point UDL is acting. Exactly at this point UDL is acting. But I want the distance from A. So this is 2 meters. This is 2 meters. From A it is 4 meters. From A it is 4 meters. So 2, this is 2 plus UDL by 2. UDL divided by 2. UDL length is 4, half of that. This is 2. So from A, it is this distance. Once you know all this, you can take all the vertical forces equal to 0. Vertical forces, these are all the vertical forces. Okay, I have taken upward as positive, downward as negative. That is one equation. You can take moment about A, and these distances I have measured from A itself. So force multiplied by distance. Force multiplied by distance. Okay. Then see the sign convention about A. 50 is clockwise, I have taken positive. 40 is clockwise, I have taken positive. UDL is clockwise, I have taken positive. RB is anti-clockwise, so I have taken negative. Okay. So I have taken negative for RB. For all the remaining things, I have taken positive. Okay. So you will get RB from this equation. I got RB as 42 from this equation. Substitute that in this equation, I will get RA. Substitute that, I will get RA. So first step is getting the reactions. I got the reactions at the supports. Now, I have taken 4 sections here. First section, which is valid from A to B. Second section, which is valid from B to C. Third section, which is valid from C to D. Fourth section, which is valid from D to E. Okay. Now, take the first section. When I take left side part, these are valid. If I take left side part of the section, these are valid. Because leftmost point is 0. So, when this is 0, this length is 2, this point will become 2. When this is 0, up to this point, the length is 4. So, this will become 4. When this is 0, up to this point, this length is 6. So, at D, x is 6. When this is 0, up to this point, the total length is 10. So, at E, x equal to 10. So, take the left side part of the section. Shear force and bending moment. Only one force is acting 88. Distance of that force from section is x. Distance of that force from section is x. So shear force is only one force, which is 88. Left side part upward positive. Okay, substitute x equal to 0, you will get the same value. X equal to 2, you will get the same value because there is no extra. Bending moment, force multiplied by distance from section. So 88 multiplied by x. Force multiplied by distance from section. Clockwise positive. Again, substitute x equal to 0, you will get bending moment at A. Substitute x equal to 2, you will get bending moment at B. Section 2.2. Section 2.2. Left side part. So here 3 forces are acting. One is reactive force 88, another one is point load 50, and third one is part of UDL. In the original beam, UDL length is 2 meters, but here only a part of the UDL is considered. Okay. Now see here. Force is 88. Distance from section, distance from 2 to up to 88. This distance x. Force is 50. Distance from section from this point up to 50. X minus 2. Because total is x, this is 2, x minus 2. UDL. What is force? Intensity multiplied by length. UDL length I know, x minus 2. UDL length is x minus 2. Intensity is 10. So intensity multiplied by length. Intensity is 10. Length of UDL here is x minus 2. So 10 into x minus 2. Where it is acting? It is acting half of this. So x minus 2 by 2. X minus 2 by 2. At that point it is acting. X minus 2 by 2. This point is, this is x minus 2 by 2. And this is also x minus 2 by 2. Now, what is the distance of this point from 2 to? This is this distance, which is x minus 2 by 2. From section up to that point, it is distance. From section up to this 50, distance. From section up to 88, distance. Shear force is net of all the forces. Left side part. So take the sign convention. Upward positive, downward negative. Bending moment. Force multiplied by distance. 88 multiplied by x. 50 multiplied by x by 2. 10 into x minus 2 multiplied by x minus 2 by 2. Substitute the x limit. You will get the bending moment. You will get the bending moment. Then Take section 4.4. So I have taken right side part of the section. I have taken right side part of the section. Because there is only one force, you can easily find the shear force and bending moment values. Because there is only one force in the right side part. That force is 42. So the force is 42. Distance from section. From section, distance up to 42 is x. When I take the right side part, rightmost point is 0. So x equal to 0, you will get the shear force at this point and bending moment at this point. X equal to 0, you will get shear force at this point and bending moment at this point. That means at E. X equal to 4, this is 4. X equal to 4, I will get shear force and bending moment at D. I have considered rightmost part. So x is 0 here, x is 4 here. X is 0, you will get shear force and bending moment at E. X is 4, you will get shear force and bending moment at D, rightmost part. Sign convention is for right side part, upward is negative, anti-clockwise is positive. I got bending moment and shear forces at E and D. Once I know all these values, I can easily draw the shear force and bending moment diagrams with the given values. These are all the salient points. So I have calculated all these values and I have plotted them. Whenever you have horizontal straight line, you will get a inclined line. Whenever you have inclined line, you will get a curved line. So horizontal straight line, you will get inclined. Inclined, you will get a curved line. Whenever you have a point load, sudden drop in shear force. 50 is the load which is acting in downward direction. Suddenly it drops from 88 to 38. So by 50 kilonewtons it will drop. Difference is 50. Here you have point load. 40. Okay. So from 18 it will decrease by 40. So 18 minus 40 is minus 22. Whenever you have UDL, you will get an inclined line in shear force. UDL, you will get inclined line in shear force. Whenever you have no load, you will get horizontal line in shear force. So no load here, horizontal line. No load here, horizontal line. In UDL, inclined line. Point load, sudden drop. When you go to the bending moment diagram, horizontal line, in bending moment, inclined line. Horizontal line, in bending moment, inclined line. Inclined line, you will get curved line. Inclined line, you will get curved line. So this is how you can draw the shear force and bending moment diagrams for simply supported beam.